everyone. Welcome back to SAT Math Question of the Day with Professor Brothers
No.
Chaiken, University of Albany, who is recovering from a parking ticket at the University of Albany. We don't want to say that. And Seth's brother Joel. Hi, we're here to hopefully show you how to approach SAT math questions and also how to approach studying for the math SAT. That's part of the whole idea here. One way to study for the SAT is to go to Khan. You already have your College Board account, and Khan offers free studying. Khan, what they do is they list the 40 or so topics that are on the SAT, and they give you 20 questions per topic. We have advanced to question 16. See, we're at the highest level. See, we're at the 4th level there. So this is question 16 of 20. We skipped the first 15. You're gonna go when you do Khan, you will do those first 15. Okay, so here we go. Question of the day. Please read it. Stop it. Do it. Stop it. Do it. Come back and let's go. We are, by the way, Seth and I are still recovering from yesterday's crash where we both made multiple mistakes, especially me. I made like 4 mistakes yesterday. Seth only made one big one. So we're still recovering from that. And it was on polynomials, so we figured we would face our weaknesses and do a polynomial question today. Ooh, Seth's already starting it. That's cheating. Okay, if A is a positive constant, which of the following equations could represent the polynomial graph in the xy plane? Okay, and this is polynomial factors. This is a cubic, right? And we have the roots. So we know that x minus, when x equals 4, this equation hits 0 because y is 0. And when x is -3, the equation also is 0. So our answer has to be this. Oh, look at this. Look at this. Look at this. It bounces off. That means it's a root of duplicity 2. So we have to square that. Okay, so what have we got? Maybe we should start knocking off some answers, right? Knock that one off. Knock that one off. Oh. Wait, what's the difference? Oh, wait a second. They're crazy. They're playing with us with dyslexia, right? It's the x minus 4 has to be squared. So that's it. So you have to know something about the root, what it means to be a root of an equation. You also have to know this thing about the duplicity of roots. What is that called, Seth? The multiplicity. Multiplicity.
Yeah,
of
4
roots, right?
is a double root.
Right, a multiplicity. When you have a multiplicity of 2, it bounces off. So now what is Seth doing? Let me see if I can guess what Seth's doing here. What does 2 plus 7 have to do with this problem?
It has to do what we did yesterday.
Okay, how does that? Okay. Oh, Seth is setting x. No, Seth's setting. I don't know. What does 2 plus 7 equal 14 have to do with this problem?
It's the mistake we made yesterday.
What does that have to do with today, though?
Nothing.
Okay, fine. Okay. So anyway, yeah. So you have to know something about that. When you have a polynomial equation, when you have any equation, you graph it. The intersection of the line y is equal to 0 and the graph f of x is where the x-intercepts. So the x-intercept is where the function equals 0. Then this is clearly where the function equals 0 because this is y. Y is equal to 0. Yeah. And then you just notice that this characteristic here where it equals 0 but it bounces off means that it's a double root.
Well, no, if it's a double root, I wouldn't bounces off. It bounces off the tangent,
Yeah.
But so it's a double root. It stays on the same side of the tangent. If it's a double root, if it's a 4th order root, it does the same thing.
That's right. but a little more funky.
But you got the converse. You got it mixed up with the converse.
Okay.
So if it's a double root, that means geographically.
Not geographically.
If it's a double root,
geographically.
The
You really mean to say geographically or graphically?
Yes, geometrically.
Oh, okay.
Yeah, geometrically, it bounces off the line y = 0 like this.
Right.
So if it's double, it looks like this.
Yeah.
The converse, if it looks like this. What kind of a root does it have?
A double.
No. If it looks like this.
Yeah.
Can you say anything about that double question mark?
Yes, it has to be an even number.
Yes.
Yes, it has to be an even number.
Yes, it has to be an even number. The order of the root is 2 only when that number is 2.
Yeah.
But 4 is an even number.
Sure.
So if you have a thing that looks like this, it may have a 4th order root.
That's right.
Which is not a double root.
That's right.
Okay. Yeah. But if it looks like if the equation has this form, if the function has this form, x minus a squared times something that's non-zero when x is equal to a, then we say it has a double root.
Right.
Yeah. Okay.
Yeah, so it can be even number, but if you go in your calculator and you play around with the 4th root, it starts to look a little funky. If you play around with the 20th root, the 20th root's crazy. The 20th root comes in. It's totally insane. You can draw it on your calculator. X minus 2 to the 20th. The graph comes in and looks like a box. It's so weird. So maybe Seth can sort of explain why that is. But that's really weird. But you go ahead,
right. Looks like a box. Yeah, right.
Yeah.
So the thing is, should we do x minus 20? X minus what?
2 to the 20.
2. Okay, x minus 2 to the 20. We want to plot y equals x minus 2 raised to the 20th power.
Right.
Okay, so what does that look like? Here's 1. Here's 2. Here's 3. So it looks like this.
Yeah, it really looks like a box.
Yeah, and that's because.
Yeah, why is that?
That's because if x is greater than 2, then this number in here is greater than 1. And really, really tiny numbers, even that are greater than 1, even very small numbers greater than 1, when you power them up to 20th power, you get a pretty big number.
Right.
So actually what happens is it's really like this, right? Except that this curvy thing here is really, really tiny. If you blow up this, if you really magnify this corner, it looks like that.
No, but why does it flatten?
Why? Because, well, I think the way to understand is take your calculator and put into your calculator. Calculate what the value of y is when x is 3 1/10.
Yeah, it's going to be a big number.
You power 3 1/10 raised to the 20th power. No, sorry, it's minus 2.
Yeah.
So if x is 3 1/10, then x minus 2 is 1 plus 1/10.
Oh.
That's right. So it's 1 plus a
Oh.
tenth. If you power up 1 and a tenth to the 20th power, you get a very big number.
So you're saying that this funky...
And then conversely, the other side, if your value of x is a little bit less than 3, like 2 and 9 tenths.
Yeah. Right.
Subtract that from 2, you get 9 tenths, and raise 9 tenths to the 20th power, and you get a really tiny number.
I see. So this canyon is always the width of 2. Wait, is that right?
That's right.
What
yeah.
about,
Yeah.
okay, if you do x minus 3 to some crazy power to the 100th, when x...
I'm going to do it. Yeah, I'm going to calculate 1.
4 and 2, then this number's less than 1, and 1 to the 100th power becomes 0 very quickly. So that's why...
It approaches 0 very quickly. It doesn't ever become 0.
Oh, I see. So the channel is always a width of 2.
Yeah.
Oh, wow. I never even realized that.
Yeah.
Oh, wow. Cool. Okay, great. Yeah. Now, similarly, you have the crazy thing with the odd roots, right? Y is equal to x minus 2 to, let's say, the 17th. That comes in and does a jiggle, right?
Oh, yeah.
That does a jiggle. That crosses the axis, but does a jiggle. And for the same reason. So this would be between... If it was 2, then this would be between 3 and 1 for the same reason. Because when you're close to 2, you have a small number multiplied, raised to some crazy exponent, which becomes 0. Very good. Right. Okay. Got it.
Yeah. So I'm going to calculate you can't see it. I'm going to calculate my calculator.
Okay.
1 and 1/10 to the 20th power.
1 and a tenth. That's a big number. Wow. Pretty big.
Well,
number.
let's calculate. See, come on. Oh, okay. Still doing drawing. Okay. 1 and 1/10 to the 20th power is, well, it's only 7. It's approximately 7.
Yeah, 6.7.
And if we take the other one, 0.9. 0.9, where's exponentiation, to the 20th. That's about 12 100ths. Yeah, but if I took 1.2, 1 2/10 raised to the 20th power, oh boy, that's 38.
Yeah. So it's okay. Yeah.
Yeah.
Wow. It's okay. So I think we're basically done.
Yeah.
Okay. Okay. Let's see then. What did they do? Oh no, we want to clear the drawings, and let's see how they do it. Oh no, we want to clear everybody's drawing. Drum roll, please. Oh, which one was it? It was this one, right? Yeah, it was this one. That's right. Drum roll, please. Okay, let's see how they do it. Check answer. Wow, we got it right today. Well, we got it right yesterday too, but through a lot of pain and torture. Okay, we know the function graph the xy plane is a polynomial function. Fine. Recall that a function, if the graph has intercepts at, okay, right, got it, is a factor of the polynomial. Very important, right? Okay, so it leaves us with this, right? Leaves us with... Yeah, it's a pretty standard way of doing it, right? Leaves us with this. Yeah. We could be more specific about the behavior. Oh, touches the x-axis as opposed to bouncing off the x-axis. They talk about an odd number, right? An even number, right? Exactly, because it touches the x-axis. We said bouncing off, but Seth, we did forget to say that it can also bounce off, to my terminology. It can also bounce off in a downward way. It can come up and bounce off.
Yeah.
So they're nice about touches the x-axis, right? As opposed to crossing the x-axis. See the distinction? So the only function to satisfy. So they're doing it by looking at the choices also, right?
Yeah.
Yeah.
Well, geometrically, there are three possibilities. There's this possibility. And this possibility, which is, these are undo.
Right, crosses and touches.
Yeah.
Those are like two possibilities. Crosses.
But there's
touches.
The other possibility when you have an odd, a non-zero odd order root, then you have what's called an inflection point.
Right. Yeah. Well, that's crossing.
Well, it's not the same. Yeah. It does cross. Yes, it crosses, but the way the direction it's moving while it is crossing. At the moment it's crossing, it's moving parallel to the x-axis.
Oh,
that's
you mean
really wild.
To a linear term, as opposed to a linear term, x minus 3 just crosses right through and doesn't waste its time being parallel.
Yeah.
Got it.
So this is y equals x minus a is
right.
a.
Got it.
And this one is about y equals x minus a cubed.
Right, to an odd power other than 1.
Or an odd power, yeah.
Other than 1.
Yeah. This is,
Yeah.
Three or more. Three odd more. Power, and this is 1.
3 or more. Right. Yeah, and integers, right? Yeah, integers. Paul, these are polynomials. Polynomials
mean well, if the exponent, it's...
Polynomials mean that you have integer exponents.
Yeah.
Right. Yeah. Okay. And a lot, for those of you slated for calculus, all of this you will get, when you take calculus, you will explore these things and get a little bit more insight. It's something to look forward to if you will be taking calculus. So. Yeah. Okay.
Yeah.
That's it, right?
All right, enough of that. Yeah.
Okay.
I think we're done.
We're definitely done with this. So have a great day, everyone. Please like us, dislike us, give us comments on YouTube videos, on our YouTube videos, and please email us your SAT math questions at SAT math question of the day. Okay, everyone, have a great day. Bye-bye.